Now in this question we're being told we've got 5 mils of 0.1 mole of sodium hydroxide. I'm going to react it with a mixture of HOBr and ethanoic acid. So we've got two acids present which will have different pKa values, and this can seem a little complex, but in a way you can treat it like a diprotic acid, which you'll have two equivalence points, and you'll get the stronger acid reacting first, and so we can base it on that. So if we look at the sodium hydroxide, we get 5 times 10 to the negative 4 moles, that's 0.005 litres times 0.1 mole per litre sodium hydroxide, and then we just have to really have a look at how much ethanoic acid we have. Well, we've got 0.2 times by 0.01 litres, and obviously in that case that's going to give us 2 times 10 to the negative 3 moles. So that means we'll have left over in the ethanoic acid, we'll have 1.5 times 10 to the negative 3 moles, and we're asked to calculate the pH, and the pH at this point is really going to be intrinsically due to the stronger acid, the ethanoic acid. So if we have that based on Ka and equals H3O plus squared over HA. So we can work out the concentration of this, which is going to be in redo. Now we've worked out the number of moles. Now we use the formula Ka equals H3O plus times by A minus over HA. Well, the A minus we kind of know. We don't have to worry too much about the actual concentration per se, because we know that this number and this number are going to be from the moles. It's going to be 1.5 on the bottom times 10 to the negative 3, and the base is going to be 0.0. I'll just write that point. I'll just write it 5 times 10 to the negative 4 rather than writing it like that, and that's just the amount that adds up to 2 times 10 to the negative 3. And then we already can work out Ka, which is approximately 4.8 is the pKa, and if we turn that into a Ka we get something like 1.58 times 10 to the negative 5. So using that information we should be able to work out the H3O plus. So if we just put some values into that equation, and that's the Ka which we got from the graph using pKa. These are just the molar ratios, and because they're a ratio we don't have to worry too much about changing them to something else. That's just 5 times 10 to the negative 4, 1.5 times 10 to the negative 3. We've just got that from that, adds up to that number of moles from the ethanoic acid, and that leaves us to work this out, which we find is 4.74 times 10 to the negative 5, and that gives a pH of 4.28. And that's that question done.